I saw that.
Alrighty. Good morning, everybody. Welcome back to Hillsdale College, if you left for fall break, and welcome back to Calc 1. Our plan for today is we're going to continue on with Standard 13. Kind of what I expect is that we'll spend today's class and probably the first part of class on Wednesday finishing up Standard 13 by talking about motion problems. And then we'll start Standard 14 in the second half of class on Wednesday, and then do our Standard 13 quiz on Friday. We've got my usual office hours for the next few days. Today and Wednesday at 11 and 2, tomorrow at 11 and 1. And as far as homework goes, post another web work assignment, homework 16 due Friday. Don't forget you have one due tonight. How's your break? Good. Thumbs up or thumbs down? Cool. I'm seeing mostly thumbs ups. Yeah, me too. Had a chance to relax a little bit. Hope you all did as well. Had a chance to catch up on my grading for my other classes, which I desperately needed. Let's see, what's the okay. So one day, a statistics professor gave out a 50-question true-false exam. Doesn't that sound lovely? During the exam, the professor notices one student is just sitting in the very back of the room, flipping a coin over and over. They would flip a coin and then mark down their exam. Flip the coin again, mark down their exam. And this continued on for the full 2 hours. And after all the other students have left, that one student is still sitting in the back of the room, flipping their coin over and over. The professor goes up to the student and says, "Listen, I know you aren't prepared for the test, and I know you've been flipping a coin to determine the answers. What I don't get is, what could be taking you so long to do that?" The student glares at the professor and says, "Shh, I'm checking my answers." Okay, so just for a little bit of review, when we left off last time, we had talked about initial value problems, which were problems where we know the derivative of a function and we know the initial value of a function. So let's say if we were looking at something like f prime of x equals, I don't know, e to the x minus 5, and we know that f of 0 is equal to 17, we should be able to use this information to solve for f of x. So this is not one in the packet. This is one I just kind of came up with on the spot as a little bit of a review, since it's been a few days, I'm guessing, since you last looked at this stuff. So if we know that f prime of x is e to the x minus 5 and that f of 0 is equal to 17, what can we do if we want to solve for f of x? Josh?
You can integrate f prime of x just to find what f of x equals.
Okay. So if f of x is going to be some antiderivative of e to the x minus 5, it looks like I wrote sex. What would we get if we integrated that with respect to x? So in other words, if we know that f prime of x has to have form e to the x minus 5, what does that tell us about what f of x has to look like? Sam?
It's going to be e to the x minus 5x plus c.
Yeah, if we integrate each term, integrating e to the x just gives us back e to the x, since e to the x is its own derivative. Integrating negative 5 will give us a minus 5x, and then we'll get a plus c at the end, because you always get a plus c whenever you integrate. So we know f of x has to look like this. It has to have the form of e to the x minus 5x plus some constant value. So what can we do if we wanted to solve for that constant value c? In other words, what would allow us to actually say what this value of c is for the specific function that we're looking at? Right?
Plug in 0 for x and then set it equal to 17.
Aha, so you want to use the fact that we know that if we plug in 0 for x, 17 should be our output. And that should be able to give us an equation that'll let us solve for c. I like it. So if we do that, we will get f of 0, which should be e to the 0 minus 5 times 0 plus c, should be equal to 17. And then that gives us then an equation that we can solve for the variable c. And that'll tell you what our constant number should be at the end of our function. So if we simplify the left-hand side of this equation, e to the 0 minus 5 times 0 plus c, what is that going to simplify to? When?
1 plus c.
Yeah, I think so. E to the 0 is going to be 1. Any number to the 0 power is always 1. Negative 5 times 0 is, who cares? So we get 1 plus c is 17. And let's see, let's get a quieter student to answer this one. Logan, what can we say about c if 1 plus c is 17?
Well, we can subtract 1 from either side. We can say that's what c is equal to, which would be 16.
I like it. Yeah, so this will tell us then that c has to be equal to 16. And then we can plug that back in to the function we got here. So that our final answer would be f of x is e to the x minus 5x plus 16. And that gives us kind of our final answer. The only function whose derivative is e to the x minus 5, and that if you were to plug in 0 for x, you would get 17 as an output to your function. And so in general, the way we said to approach these is to always take this approach, where if you know f prime of x, integrate to find a general formula for f of x, where you probably have like a plus c term at the end, and then use your initial value, in this case f of 0 equals 17, to help you solve for whatever that constant term she should be equal to. Yeah, she. Questions or comments? So today I want to take a little bit of a different approach to start things off. We'll be coming back to these initial value problems in the second half of class. But I want to look at some specific word problems that involve these expressions. Specifically, problems that are looking at motion. So I'm going to be on the page where it says at the top, in general, we know that if an object moving in one direction has blah, blah, blah. So if we know that s of t equals some position function, that kind of harking back to the early days of the class when we were looking at problems of like if we're in a car moving along the highway in various directions. If we define a function where s of t is going to be the distance from starting point after t units of time, where depending on your problem, t could be measured in seconds, minutes, hours, years, etc. What do we know about the derivative of our position function, or our distance traveled function? Throw the word net in there. Anna?
It's the velocity.
Yeah. If we differentiate the distance traveled, differentiating distance gives us velocity, or instantaneous velocity at a single value of t. So we can say that s prime of t, which will be v of t, is going to be the velocity at time t. In other words, how fast are you moving? What would we get if we took v prime of t? If we differentiated the second time and took the derivative of our velocity function? Josh?
Wouldn't it be like change in velocity, so that'd be acceleration.
Yeah. If we differentiate again and take v prime of t, or s double prime of t, we're going to get acceleration. At time t. So we haven't looked at acceleration yet, but if you're thinking about, like, if you're driving along in the car, whatever your speedometer is telling you is going to measure velocity. So, like, for instance, if this is measured in miles and you're traveling in your car, your speedometer is going to give you units of miles per hour for velocity. And if you want to think about what's acceleration doing in this case, you might be thinking about if you push down on the gas pedal, so your velocity is increasing, your car is speeding up, then you're going to be moving with a positive acceleration. Whereas if you slam on the brakes instead, and your car starts to slow down, hopefully quickly if you're slamming on the brakes or you might be in trouble, you're going to be moving at a negative acceleration, even though you might still be moving forward. You'll just be moving forward slower and slower and slower as time goes on if you keep holding down on the brakes. So if S of t is measured in miles and V of t is measured in miles per hour, what would V prime of t, or acceleration, do you think be measured in?
Miles per hour squared.
Yeah, it's going to be miles per hour squared. Or miles per hour, if you prefer, if you're one of those crazy people out there who likes fractions within fractions. So in general, the rule of thumb for units going from distance to velocity to acceleration is whenever you differentiate, you divide by your time unit, which if we're measuring time in our problem in, say, hours, going from our distance function to velocity function, we're going to go from miles to miles per hour. And if we differentiate again, we'll go from miles per hour to miles per hour squared. And replace miles with whatever your distance measurement is, replace hour with whatever your time measurement is, in looking at your derivative. So I want to look at an example problem where, because everybody loves pirates, or should, we're going to look at a problem where we're shooting a cannon up into the air. And let's say, to start off with, I give you a function that tells you what is going to be the cannonball's height t seconds after being shot. And let's say that t seconds after being shot, we know that our height function is going to be s of t is equal to negative t squared plus 8t plus 10 feet off the ground. Which negative 2t squared plus 8t plus 10 is going to give us a parabola, since it's a t squared type function, which if we were to shoot, would start off at some point, some height here, would go upwards, and then arc back down until it eventually, let's say, hits the ground. So this is going to be a graph of sort of what the trajectory is going to look like. Whereas time goes on, since we have a downwards opening parabola, downwards because the coefficient on our t squared term is negative, our cannonball is going to start by going up into the air, and then it's going to go downwards until eventually it hits the ground. be the velocity in terms of change in height of our moving cannonball, do you think? In other words, right now we have a height function. How can we come up with a function that'll tell us after t seconds what's going to be the cannonball's vertical velocity, moving upwards or downwards? What?
The derivative of the height function.
Derivative. So if we differentiate our height function, negative 2t squared plus 8t plus 10, let's see, how about, Elise, what is that going to give us if we were to differentiate our height function?
Negative 4t plus t.
Let's see, derivative of negative 2t squared will give us negative 4t, derivative of 8t will give us 8, derivative of 10 will give us 0. I like it. So we could say that our velocity is going to be given by negative 4t plus 8, which should be our unit. Rachel?
Feet per second.
Yeah, since our height function was measured in feet, our time measurement is given in seconds, our velocity should probably be measured in feet per second. So that tells us if we were to plug in a value of t, like say t equals 1, we would get that v of 1 is negative 4 plus 8 is 4 feet per second, which would probably tell us that at t equals 1, since v of t is positive, that's going to be a point on our graph where the cannonball is still moving upwards. It's still arcing upwards and hasn't started to fall yet. In fact, if we take our tangent line to s of t at t equals 1, we would get a slope of 4 coming from the fact that s prime of 1 would be equal to positive 4. What if we wanted to find acceleration? In other words, the vertical acceleration, which tells us how fast is our cannonball going to be accelerating in a vertical direction. Right?
Just take the derivative of velocity.
Okay. So if we do that, we need the derivative of negative 4t plus 8, what's going to be our derivative of negative 4t plus 8, Tyra?
Negative 4 per second squared.
Negative? Ooh, very good. I didn't even have to ask for the units. It's going to be negative 4 feet per second squared. What do you notice about our acceleration that's different from our acceleration formula that's different from our velocity or height formulas? Right?
It's just a constant.
Yeah. It's going to turn out that vertical acceleration is going to be just a constant. On Earth, this would come out to about negative 32 feet per second squared, so, I don't know. This is taking place on Mars, not on Earth. But in general, in an acceleration problem like this, acceleration on a planet is typically going to come out, or vertical acceleration at least, is going to be a constant value. Negative 9.8 meters per second squared, negative 32 feet per second squared if you're on Earth. And no, you don't have to know those. If I want you to use those, I'll give them to you. But acceleration vertically done is constant, meaning our velocity is always becoming more and more negative as time goes on. If we were to graph the tangent lines at various points on our graph, their slopes are always going to be getting more and more negative at a rate of negative 4 feet per second squared. Any questions or comments about height, velocity, and acceleration? So if you all turn the page I'm going to give you all a couple minutes to look at a few different questions. I want you to answer me these questions 3. I'm sounding like a Riddler or a genie or something. First of all, I want you to tell me what's going to be the height of the cannonball at the time when the cannon is fired. So in other words, how far does the cannonball start off of the ground? Because it's going to turn out to be the case that we're not firing this cannon from ground level. Second thing I want you to look for is at the point in time where our cannonball has reached its apex. I'll label this A to tell you this is the first thing you're looking for. Second question, B, is what's going to be the cannonball's height at the point in time where the cannonball reaches its highest point? It's the apex of its trajectory, the highest it's ever going to get. And finally, I want you to tell me at what point in time is the cannonball going to hit the ground? So in other words, how long, what value of t is it going to be where the cannonball's height becomes 0? So go ahead and take a couple minutes, and as always, you're welcome to work with your neighbors, talk to the people sitting around you, as well as to ask me any questions you might have, and see if you can find these 3 values. The height at time 0, the height when the cannonball is the highest point it can possibly reach on this graph, and finally, the value of t where the cannonball hits the ground.
At t equals 2, because the velocity is going to be the vector. Because that's yes, but that's going to be and then so then you put 2 into yes, and then you put your answer.
You put ST equals 0.
Oh no, yes. There's only so into the no. So you put because the apex is right here. Right. Yeah. And so the slope will be 0, which is
I'll give you all a hint. It sounds like I'm hearing a couple of you mentioning this already. For part B, notice that at the apex of its trajectory, the slope is going to have some interesting property to it. If we were to draw out the tangent line at this point. Here we are.
and then you put the answer to that in the back of the question. Okay. No, I know. I'm right. Okay, and then the next one, it's put, so that's when it's when the 0. So you put 0 equals negative 2t squared plus 8t plus 10. Just spare this second. You can use the quadratic formula. I have a song. Me too. You can just say it really fast. And so then the answer is negative 1 and 5 to 6 times.
You're not quite sure where to start on something, I encourage you to talk to your neighbors and or flag me down.
Oh, yeah.
How long does it take for the can's
T equals 2.
No, I haven't looked at it yet.
Let's say I think you're halfway there.
Looks good.
That's the if you say so. Go ahead and take another minute or so, and then we'll come back together to talk about these as a class.
You put it equal to 0. Yes.
Let's see. I don't think you want to set. I think the best way to do this is probably going to be to factor.
For the B, you do the
And
velocity.
it might help to factor out of
I'm not good at
Equals for B.
and then whatever's
You
left
take
is
velocity,
something and it does
which
factor.
is negative 4t plus 8. You gotta set velocity equal to 0.
The other way with a couple other with the
Speed
two
is
other
0 because it's changing positions. So it goes from positive to negative. So at some point it has to be 0. When you
didn't
what?
show up.
When you plug in 0 to that equation, you get you plug in 0 for like y, so it's like v of t equals 0, so 0 equals negative 4t plus 8. Solve for t, then you need to plug t into the equation, I think, or am I right? I don't want to tell them something wrong.
I think you might be onto something.
Sorry.
So, something
I
like
was a
that.
Spanish minor at middle school.
Something like that.
I'm kind of afraid of the Spanish department.
Yeah. And it's weird, the whole Spanish department retired last year almost, except for Dr. Mack. And so had to bring in a bunch of new blood this year. So Spanish department's kind of an unknown in the college right now.
I really liked my Spanish class in middle school. It was with the seminarians.
Okay, let's come back together and talk about some of these, because as I kind of walk around the room, I'm seeing some interesting ideas that you all are having. So first of all, how can we find the height of the cannonball when the cannon is initially fired? Is it?
Plug 0 in for t on the S of t equation, and then that just gives you 10.
Okay, so if we know the time, if we know the height at any given value of time, then we could just plug in t equals 0 to say at time 0, what's going to be the height of the cannonball? I like it. So if we do that, we'll get s of 0, which is negative 2 times 0 squared, plus 8 times 0, plus 10, is indeed going to give us 10
Feet.
10 feet. I like it. So in other words, we know the height at this point in time is just going to be 10 feet for part A. How about finding the height at the apex? Because that one looks a little bit trickier to me. You know, what were your thoughts on this one?
So the slope of the line of the derivative at the apex is horizontal, so it's 0. And the derivative of s of t is velocity. So you can set the velocity as 0. And that's the time that is at the apex.
Okay, so you noticed, you made a good observation, I think, Anna, which is that at time, whatever point in time this is, we have a slope, s of t has a slope of 0. It has a flat tangent line. And so if we set v of t equal to 0, that should allow us to then solve for what is that point in time. So if we do that, we'll get negative 4t plus 8 is equal to 0. How did you solve that for t?
You just subtract 8 from both sides and then divide it by -4.
Which will give us t equals
2.
2.
And then, or, sorry, seconds.
Is a, for finding the value of t, I think we should be using our time.
I agree. And then,
I'm glad you agree.
and then you can put 2 in for the height equation, and that'll give you the height of the apex.
Ah, okay. Yeah, because the question asks not at what time does the cannonball reach its apex, but what is the height at that point in time. And since now we have a value of t for our apex, we can just plug that into s of t and solve for what's the height at that point. So if we do that, we'll get negative 2 times 2 squared plus 8 times 2 plus 10. 4 times 2 is negative 8 plus 16 plus 10 is going to give us negative 8 plus 16 is 8 plus 10, I believe, is 18. That's keep me straight. There. Yeah. Looks like it's going to be 18 feet at the apex. Any questions or comments so far? And I like that you took the derivative, set it equal to 0, because there's only one point on our graph where we have a horizontal tangent line, which is at the apex. We found the apex has to occur at 2 seconds. So at 2 seconds, our cannonball is it's not rising anymore, and it hasn't started falling. It's kind of suspended in the air at the highest point it's going to reach before it starts splashing down or falling down. I don't know, depends on if we're fighting at sea or at land. And then to find out what's going to be the height at that point in time, we just plug in that point in time, t equals 2, into our height function, and got that s of 2 came out to 18 feet. So finally, for our last question was, how long does it take for the cannonball to hit the ground? Kenzie, what was your approach for this?
Well, when the cannonball hits the ground, the height is 0. So I set s of t is equal to 0.
Okay. Yeah, sounds reasonable. When the cannonball hits the ground is at a height of 0. So we can set s of t equal to 0 this time, rather than v of t. So if we do that, we'll get negative 2t squared plus 8t plus 10 should be equal to 0.
I factored negative 2 out of the equation.
Ooh, okay, so when you factored out a negative 2, what did that give you?
T squared minus 4t minus 5.
Sounds good.
And then if you factor the polynomial, you get negative 2 times t minus 5, and then t plus 5.
T minus 5 times
T plus 1.
t equals 1. Let's see, if we multiply that out, we get t squared minus 5t plus t, so minus 4t minus 5. Yep, I'm on board.
And then you can divide 0 by negative 2.
Okay, cancel out the negative 2 on both sides. It'll still give us 0.
So then t equals 5 and negative 1, but since time can be negative, the answer is t equals 5.
Yeah, it's interesting. We seem to be getting a negative number. We seem to be getting 2 values of t out for our answer. This is going to give us that t is either equal to 5 or to negative 1. And you want us to discard the negative number? So for our final answer is going to be t equals 5 seconds. I like it. Yeah. So it turns out that at t equals 5 seconds, our cannonball is going to hit the ground. But Dr. Gerstle, what about the negative 1? Well, it turns out the negative 1, if we continued our parabola for negative values of t, it would intersect the t-axis again at t equals negative 1. But for our scenario that we're looking at, it doesn't really make sense to look at negative values of t. It's not like the cannonball is going to be buried in the ground 1 second before we fire it. It's probably just going to be sitting wherever and being prepped for firing. And so, Mackenzie, I like how you said that it doesn't make sense to talk about negative values of t here. So we're only going to use the positive value we would get, which is t equals positive 5. I saw some of you using the quadratic formula to solve this equation. That is perfectly acceptable as well. A little bit ugly with square roots and stuff, but you should come out with the same 2 values of t in the end. like grinning from the middle of the room. Any questions or comments about any of these problems? So this kind of tells us how we can sort of find the relationship between height of a moving object versus its velocity versus its acceleration. And depending on what the question is asking you, you have to kind of interpret what exactly you need to find. For like the maximum height, we needed to solve where v of t was equal to 0. Time when the cannonball hit the ground, we needed to solve for when s of t is equal to 0. Initial height, just plug in 0 for t into s of t, find the height at time 0. And depending on what the question's asking, you'll need to interpret which function do you want to use and what do you want to do with it. Dr. Gerstle, what does this have to do with these initial value problems that we started class off with? Well, here's the thing. In this scenario, I was nice to you and gave you a formula for s of t to start with. And then you all differentiated s of t twice, once to find velocity, once to find acceleration. Actually, we never really used this one, but you can differentiate if you're starting with the height function to find velocity and acceleration. So what if I twist things around on you, and instead of giving you the height function to start, let's say I give you the acceleration function as your starting piece of information. So in this new scenario, we're going to be supposing that I'm going to be tossing a ball straight up in the air. I don't have a ball, so I'm going to use a piece of chalk instead. Is everybody watching? Threw it a little too hard. Probably shouldn't be chalking up the ceiling. What happened? I threw it up in the air.
It went up, then it went down.
It went up until it reached the apex of its trajectory, which happened to be the ceiling height because I threw it a little too hard. Let's pretend the ceiling's not there. It went up, and then gravity eventually sucked it downwards until it hit the ground, I don't know, a second or so after I threw it. So here's our scenario. We're going to know what the acceleration is of our ball. It's going to come out to a constant value. A of t equals negative 32 feet per second squared. That's our formula for what the acceleration is, and in fact, is kind of the constant acceleration value you would get if you tried to do this experiment on Earth. It's always going to be negative 32 feet per second squared. Acceleration will be constant, although, as it'll turn out, velocity and height will not be. We also know that at the time when the ball is thrown, the upward velocity is 16 feet per second. So in other words, at the point in time when I threw it upwards, I didn't just drop it, I threw it upwards, so it had a positive initial velocity to start of 16 feet per second. And finally, let's pretend Dr. Gerstle is a giant. Or maybe I'm standing on a building doing this, throwing it upwards or something, I don't know. But let's say the ball is thrown upwards from an initial height of 96 feet off the ground. And our goal is, given these three pieces of information, what I want to do is I want to find a formula for the ball's height after t seconds. So now, instead of starting with a formula for height and finding a formula for acceleration, we have to go backwards. We're starting with a formula for acceleration, that it's always a constant value of negative 32 feet per second squared. And we want to work our way backwards to be able to find a formula for what our s of t, what our height function is going to be after t seconds. So first of all, when I'm given a problem like this, I like to take each piece of information and see if I can write it in terms of some formula that could be potentially useful to us. So our first piece of information, well, that's already a nice formula. A of t is always negative 32 feet per second squared. How can we write the second piece of information in terms of a formula that at the time when the ball is thrown, its upward velocity is 16 feet per second? So in other words, how could we say some function at some point in time is going to give us 16 as an output? Josh, what are your thoughts?
V of t equals 16.
V of t equals 16? Always for all values of t?
V of, would that be V of 0 or V of 1?
Oh, when the ball is thrown, at the time when I let go of the ball, if our scenario is, if we want to find a formula for the height t seconds after I throw it, what do you think?
V of 0.
Yeah, I think V of 0 is going to be 16. If V of t was always 16, that would imply I'm in space throwing it upwards and it just kept going up and up and up forever, which isn't going to be the case, but at time t equals 0, 16 should be our output to our velocity function. Zach?
Well, you just integrate a to t.
Whoa, hold your horses. We're not done yet looking at our initial information.
Well, that's what you gotta do to find v of t.
Well, yeah, but I'm not ready to do that yet.
Oh, that's where we're getting to.
Yeah, that's going to ultimately be our approach, but I like to start by interpreting all of our information first into a formulaic form, and then so let's look at this third piece of information first. Then I'll come back to you, Zach, and we'll do what you suggest. So how about this third piece of information? The ball is thrown from an initial height of 96 feet off the ground. Elise?
That would be S of t.
S of t equals 96?
Yeah, S of 0 equals 96.
Yeah, I like S of 0. Of course, where the fact that we know it's S of 0 is we said that its initial height is 96 feet off the ground. Initial meaning at time t equals. If S of t was a constant 96, that would imply I threw the ball and it just hovered there in midair forevermore at 96 feet. Should be pretty cool, be a pretty nifty magic trick, but that's not what's going to actually happen. Unless we're in space. If we were in space, we'd get A of t is 0, not negative 32. So here's our three pieces of information. We have our A of t is negative 32. A of t is going to be constant, negative 32 feet per second squared. Our V of 0 is 16 feet per second, and our S of 0 is 96 feet. So the question is, how can we combine these three pieces of information to find a formula for S of t? And Zach, I know you were itching to offer a suggestion earlier, so I think now's a good time for it.
Well, if you integrate a to t, you're gonna know it's gonna be negative 32 t plus c. We already found what c is, but v equals 0, so that's your equation. It'll be negative 32 t plus 16.
You're just gonna do the whole problem if I sit here and let you, aren't you?
Oh, no, I was just doing that for you.
Okay, well, so let's write down what Zach has proposed. So, Zach, you proposed we start with our formula for A of t and integrate to find a formula for velocity? Okay. So what do we get if we integrate our constant value of negative 32?
Negative 32t. Plus c.
Yeah, so that's going to tell us that since acceleration is the derivative of velocity, that tells us that velocity should be an antiderivative of acceleration, which is going to tell us that for some value of c, v of t is going to be equal to negative 32t plus some constant value. Somebody other than Zach, what can we do in order to solve for what this constant value c should be equal to? Alan?
You would plug in 0 for t, and then for vt you would put in 16.
Ooh, okay. So you want to use this piece of information, that v of 0 is equal to 16. I like it. We're going to use our initial value, in other words, for v of t, in order to solve for our constant term. So if we do that, we'll get that v of 0 is negative 32 times 0 plus c should be equal to 16. And if we solve that for c, what are we going to get, Helen?
I got 96.
Negative 6 for c?
16.
I was going to say, I think this actually just simplifies right away to c equals 16, because negative 32 times 0 is just going to give us 0. And so we can use these first two pieces of information, our knowledge of what a of t equals and our initial value for v of t, to find that v of t has to be equal to negative 32t plus 16. What's our units? What's that? I heard someone whisper.
Feet per second.
Yeah, so v of t is going to come out to negative 32t plus 16 feet per second, using these first two pieces of information. So in other words, since we can differentiate velocity to give us acceleration, we can integrate acceleration to help us find what's the velocity going to be. And then, since we have this unknown constant value at the end, we would need some sort of initial value, like v of 0 equals 16, in order to help us solve for c and get an exact formula for what v of t should be. Problem is, the question didn't ask us to find a formula for v of t, for velocity. We were asked to find a formula for height after t seconds, for s of t. So what can we do if we want to find a formula for what s of t should be equal to? Rachel?
You would integrate v of t.
Integrate v of t. I like it. For similar reasons to why integrating acceleration should give you velocity, it's because the derivative of velocity is acceleration. If we were to integrate velocity, that should give us height, since the derivative of our height function will give us velocity. So if we do that, we integrate negative 32t plus 16. Rachel, what's that going to give us?
Negative 16t squared plus 16t plus.
And negative 16t squared plus 16t plus some constant. And I'm going to use d instead of c, since we already had a variable c earlier in the problem. We found was 16, and the constant we get here, I suspect, will not be 16. But yeah, I like it. Integrating velocity gives us height.
Could we still, like, during like an exam or a quiz, could we still use C? Or do you want us to use a different variable?
I want you to use a different variable. I mean, it's a pretty minor thing. Like, double using C is not the sort of thing that you would lose a mastery over. But technically it is better to use a different variable because this constant value is probably going to be different from that constant value. And you don't want to use the same variable name to refer to two different things.
Thank you.
Okay, good question though. So, we know what S of t is, except for this pesky constant term at the end. What can we do if we want to solve for d? Well,
Set the equation equal 96, and then you plug in 0 for t.
So you want to use our third piece of information that the problem gave us. In other words, that S of 0 comes out to 96. And that should give us our initial value for S of t should then allow us to solve for d. I like it. Yeah. If we plug in S of 0, which is negative 16 times 0 squared plus 16 times 0 plus d, that should come out to 96. And so, well, when we solve our equation for d, what is that going to give us?
96.
I think so. Owing to the fact that negative 16 times 0 squared plus 16 times 0, those just come out to 0. So this really just gives us the equation d equals 96. And so our final answer for S of t at this point, I think is going to be negative 16t squared plus 16t plus 96. Eight. I like it. In essence, the process that we did here is pretty much the same process we did last time. Or if you remember in class on Wednesday, we had a function where we had f double prime is 60x. F prime of 1 equals 10. F of 2 equals 41. Solve for f of x. This is a few pages back in the packet. We did this problem in class on Wednesday, and if you remember, we actually ended up doing pretty much the exact same process that we did just now. We integrated f double prime of x and used an initial value for f prime to solve for f prime of x. And once we knew what f prime of x was, we integrated again and used our initial value for f to solve for f of x. In essence, that's exactly the same thing we had here. We were given a formula for s double prime of t, an initial value for s prime, and an initial value for s, where we integrated s double prime and used our initial value for s prime to solve for s prime of t. That gave us our velocity function of negative 32t plus 16 feet per second. And then, once we know what s prime of t is, we can integrate a second time and use our initial value for s to find s of t, which gave us this negative 16t squared plus 16t plus 96 feet. It was exactly the same process, except since this was a word problem, we also had to kind of interpret each of these. And Zach, this is why I like to start by kind of interpreting each piece of information like this in formulaic form, because I find it easier to just have all my formulas in front of me at first, and then we don't have to worry about the word problem part of it as we work through. Once we kind of interpreted all this, then it was exactly the same as this problem we did last time. This was different names for our variables and such. Any questions or comments about what we just did? Dr. Gerstle, I like that last problem where you gave us S of t and asked us to find A of t better than this one. Well, tough luck. Because in the real world, on planet Earth, we're not always going to have a nice formula for S of t, for the height of your moving object. But A of t, we're always going to know if we're on the planet Earth, vertical acceleration due to gravity is always going to be a constant value. This negative 32 feet per second squared or negative 9.8 meters per second squared, excuse the wrong units, or pick your favorite form of this. On Earth, it's going to be constant. So in the real world, you're typically going to know what your A of t is and have to find V of t and S of t rather than the other way around. But Dr. Gerstle, what about air resistance and stuff? Shut up, don't make me throw my chalk. Yes, in the real world, this gets more complicated when you introduce the ideas of air resistance and friction in the air and blah, blah, blah. We're not going to talk much about those in here. Take physics if you want to learn more. Any questions, comments, or concerns? Follow-up question. Back to the right page in the packet. How long does it take for the ball to hit the ground? How would we answer that? I wanted to ask, now that we know what our A of t, V of t, S of t are, how can we find the point in time, the value of t, at which our ball plop hits the floor? Yeah?
You can set S of t to 0.
Set S of t equal to 0. Say that our height at the point where it hits the floor is when our height is 0. So if S of t equals 0, that can then give us a value for t where our ball hits the ground. So if we do that, we'll get S of t equals negative 16t squared plus 16t plus 96 is equal to 0. Holy moly. I do not want to have to use the quadratic formula on this. Kenzie?
Factor out negative 16.
Ooh, factor out negative 16. Okay? If we factor out a negative 16, what's that going to give us?
T squared minus t minus 6.
Like that? Let's see, negative 16t squared is negative 16t squared. Negative 16 times negative t will give us a plus 16t. Negative 16 times negative 6. 16 times 6 is 32 times 3 is 96. I like it. We'll come up to this.
And then you divide both sides by negative 16.
Okay, so that'll give us t squared minus t minus 6 is 0.
And then you can factor t squared minus t minus 6. So that gives us t minus 3 and t plus 2.
T squared minus 3t plus 2t will give us a minus t. Minus 3 times plus 2 is minus 6. Sounds good.
T equals 3 or t equals negative 2. And then again, t equals negative seconds. But t equals 3 is the only answer.
Why not t equals negative 2?
In this case, it doesn't make sense for time to be negative.
Just like in kind of the cannonball problem? Yeah, I like it. Doesn't make sense to have a negative value for t here. So I think how long it's going to take to hit the ground? It's going to be 3 seconds. Since I don't let you, and yes, since I don't let you use the calculator on a quiz or an exam, if I give you a problem like this, which I probably will, and it'll be something like this that actually factors pretty nicely. So if you find that you're getting something that doesn't factor, you might want to check your previous work. But yes, Riley.
Would it be okay if we did use the quadratic formula but didn't simplify it on this?
So if you said something like, oh, Dr. Gerstle, t equals negative 16 plus or minus the square root of 16 squared minus 4 times negative 16 times 96 all over negative 32 seconds, like that. Better make sure you did everything else absolutely perfectly or I am taking away your mastery. But yes, otherwise that's fine. If you do it this way, I'll give you more leeway in making little mistakes on the rest of the problem. How about that? Yes, technically this is correct, and I prefer you to do it this way because I want you to get an exact answer for t if you can. But yes, I realize in the real world you would have a calculator and you could plug that in and see, oh, that's 3 and negative 2. Let's go with 3. So yeah, that's fine.
I'm a little confused. Why is 3 positive now after it's been subtracted from t? And I'm a little confused about the signs.
How did we go from t minus 3 times t plus 2 to positive 3 and negative 2?
Yeah.
I don't know. Mackenzie, why did you say 3 and negative 2?
Well, if you have t minus 3 equals 0, and you add 3 to both sides, then you get t equals 3. Same thing for negative 2.
Yeah, I think it's because we kind of skipped a step here in that if t minus 3 times t plus 2 is equal to 0, that tells us that either t minus 3 equals 0 or t plus 2 is equal to 0. Because if you're multiplying two different terms to get 0, that means one of the two terms, in this case t minus 3 or t plus 2, has to be 0. And then if you solve for t in either of these cases, t minus 3 equals 0 has a solution of positive 3 for t, and t plus 2 equals 0 has a solution of negative 2 for t. Does that make a bit more sense? It comes from the fact that you're setting these equal to 0 and solving for t. Right, that's going to do it for today. When we come back on Wednesday, we're going to look at some more motion problems, and then if we have time in the second half of class, start looking at linearizations in Standard 14. Hope you all have a good rest of your day, and I will see you all on Wednesday. Don't be shy about coming down to office hours if you want to talk about anything.